So in addition to what you guys said, one reason to do your analysis in kind of text interface, a programming language, instead of using a point-and-click graphical interface, is that when you're done with your analysis, you have this really nice like recipe of everything you did. So every line you write down, you'll save it in a text file or a special Python file, and that will be on your computer. And when you come back to this data or this type of analysis, like 1 year later or a few months later, it will all be there. And if you run that file with the same data, exactly the same thing will happen as happened last time you did it. If you would do this in something like Excel instead, there would be some pattern of it you pointed at and clicked, and you would select some cells, and then you would click something else. And remembering exactly what you did down the road can be quite difficult. Yes, you can write macros and things like that in Excel, but if you like writing macros, you'll love writing Python or R, because that's essentially like a bigger, more extended version of that language. It's also easy for collaborators that you don't have to explain exactly what to do, like go here, click there. You can just, like, this is my file, this is my raw data. If you do this, you'll get exactly the same results that I get. So it's not only great for yourself, it kind of increases the chance that someone will be able to reproduce what you did. And that's really important. And that's one of the things I really like with doing programmatic data analysis instead of graphical one. And one thing, it might be a little bit intimidating initially if you've never kind of communicating with a computer through text before. But you don't have to worry. Like, I usually think of it like learning a new language, like when I learn English or something. Initially, it is nice to have a book, like a dictionary where you can look things up. You can be like, okay, this word means this. This word means this. I put these words together, get a sentence. That's kind of like, you go to the data menu in Excel. Okay, I want to do that first, and I want to do that. It's kind of nice to have those menus that sections it into things, so it's easy to discover it. Versus that you're in a Python prompt and you're like, oh, what am I going to type now? I don't know. But we'll go through some of the help systems on how you can know what to type. And once you get familiar with it, it's also really, it's a lot more nicer to have this text interface, because for me, I feel very restricted if I use say Excel or something, because even if I know what I want to do, I have to move my mouse up to that corner and click that menu and then go there, etc. Okay, there are shortcuts, but you can be even faster if you just type things out. In the same way, like once you master a language, you just speak it. You don't want to go into the dictionary and look up every word. That'll take a lot of time that you don't need to spend. I think we'll get into programming now. We'll skip that. Yeah. So, okay, how do you speak Python? So to speak Python with a computer, you first need to have something that's called a Python interpreter. And that's something you all have. So most of you have installed Anaconda now. Is someone who does not have Python installed and want it installed? Okay, can one of you guys? And if you ever have any questions throughout, you can ask me. If you have some like error on your computer, just raise your hand and look at Lina, Elliot, or Sarah, and they'll like come over and help you sort that out. So yeah, so you don't have to do this. I'll just show you. Like the most basic way of using Python would be that you have some kind of terminal and you open the program and you get what's called a prompt. I'm going to make that bigger so you can see, and we're going to remove that. So when you launch a program like Python in its simplest form, it's going to print some information about which version you're running, and you're going to get like a little prompt here. This thing is blinking, it's prompting you to enter something. That's why it's called a prompt. The entire thing is called an interpreter because it's going to interpret what you write so the computer understands. So I could use Python from here, and like as soon as I write something, I hit enter, it will output the results back to me. So I can use it as a very fancy calculator if I so wished. However, when we use Python for data analysis, usually this part is kind of bundled in a bigger interface. Some examples of that would be IDEs, which are interactive developer environments, where you kind of have nice graphical elements that like displays all your variables or makes things easier to discover. And we're going to use one such interface today. The interface we are using is called the Jupyter Notebook. If you have Anaconda installed, and now you can follow along. If you have Anaconda installed, you can go to the Anaconda Navigator and open that, and then there should be a little tile that says Launch Jupyter, or Jupyter as it's spelled. Yeah.
Sorry, can you repeat that?
Yeah, if you open Anaconda Navigator, on your, so you just go to your Windows menu or to Spotlight if you're on a Mac, search for Anaconda Navigator, that pops up. This should be a tile that says like launch Jupyter or launch Jupyter, as it's, that's the spelling. And then just try to click that.
Launch Jupyter?
Yeah.
Does it have lab, Jupyter Lab?
You have Jupyter Lab. Okay, yeah, Jupyter or Jupyter Notebook or Jupyter Lab. If you have either of those, just click launch, and that should open a tab in your browser that looks something like this.
Is it just like an editor?
We'll talk a little bit more exactly what it is now. It's kind of like an editor and more. So is anyone having a problem getting to something that looks like what I have on the screen right now? Please raise your hand and we'll come around and help you.
Oh, sorry, it works.
It works?
Just look inside you, share our screen so that I can.
Okay, so if you're here, what we want to start now, there are many different things we can do in this Jupyter Lab or Jupyter Notebook environment. What we want to do for the purpose of this lecture is to start what's called a Jupyter Notebook. I won't go through, so you click on this little tile, or if you don't see that tile, you can also go to File, New, Notebook. I can't make this bigger, yeah. And then you should get to something that looks something like this. And if you can't get here, please raise your hand. So you can see already one similarity with what I just showed you. There's a little blinking thing here. Again, it's prompting you to enter something. You can think of this small part as very similar to the kind of black screen I showed you before. And if you write something here, like 4 + 4, and then hit this play button, it will execute that. We'll execute that command and display the output just underneath. The way we saw it before, the things are just like executed in the terminal and it's just text all the time. Here it's a little bit nicer interface and we call this input cells and we call this output cells. And that's kind of how the notebook is structured. And one of the nice things with this is that we can do more than just coding in this interface. So for example, this first part here, that's just code. And you can see that because the type of cell that we're using is what's called a code cell. If I want to take some notes for myself, I can go to the next cell and I can say, and if you don't have a next cell, you can click here, which adds a new cells. You can say, okay, instead of code, I want to use this format, which is called Markdown, which is just a type of writing format. And I can write notes about what I wrote up there. Like this is how I do addition. Yeah. And if you don't want to go up and press this play button every time, you can press Shift Enter, which will execute the cell and kind of move your cursor to the next cell. So the reason we're using this interface, and we can't go into too much detail today because we only have a 1-hour lecture, but it is that you can kind of interweave these other elements. So now I have a code cell here, and if this would be something more complex to generate a complex graph, it would be nice that I could write down my notes just under it and kind of prepare it both for if I'm going back to look at this analysis later in time, or if I want to send this to a collaborator, if I want to send this to my supervisor, you can kind of write your entire report here and you can share it with people. Of course, you can share it with people who have Python installed. Then you can just save this notebook and send the notebook. If you want to share it with someone that does not have Python installed, there are several options for exporting these notebooks. So you can go to File and Export Notebook, and you have all these different options. I find that HTML and PDF work really well if I'm sending things to my supervisor because he usually knows what to do with that. And yeah, and then it will display very similar to how it's displayed here. The one other thing I want to mention before we stop talking about the Jupyter Notebook and talk more about how to do things in Python is, well, actually, I'll mention that later because we'll get into that later. Okay, let's talk more about Python. So you can do math, as we just saw, and you can also do other mathematical things that you're probably used to, or you might or might not be used to. So you can do variable assignment, which is that you're now using this equal sign to assign the value of 5 to the variable name A. So if I do that and then print A, or then just display A, you'll see it there. I'm just going to do this so that my output is not too far down, and you can always see. So now I can do operations on A instead of operations on 5. So I can do like A times 3, and that'll be 15. And I can create variables that are named anything. It's totally up to me. We can call it, it's my variable equals 2, and then if I just press enter instead of shift enter, I can edit like the next line in this cell. So if I here say, okay, A plus my underlined variable, and then hit shift enter, it'll execute both these lines. So that was 2, A was 5. So if we add 5 and 2, we get 7. Any questions on that part? Is something that doesn't make sense with like this? Nope. Good. So you can store values that are not numbers also, like text in variables. For example, I can say that B equals hello, and C equals universe. If I say if I do B plus C, what do you think will happen when I hit shift enter here? Well, you can kind of cheat and figure it out on your own and then say it. And yeah.
I mean, it'll complain. It'll say you can't do it with the type of character string.
So that's a good guess. However, in Python, you can actually do it, and it simply adds the strings together. But in many languages, it works as you would say. I found it super intuitive, and I should say that the reason I use single and then double quotes is just to show you that those are interchangeable. If you want to define a string, you can choose either use single or double quotes, as long as you use the same on both sides.
Like HTML.
Yeah, and a lot of other languages as well, probably.
And what if you have a number?
If I do like A plus B, you mean?
Yeah.
Now it says it can't add those two together because one of them is an integer and one of them is of a string type. I could do something like, okay, this is not super important to know now, but just for reference, if I want to add these things together, I could say that, okay, I want to change A from an integer to a string. I'm using a function that's called str. We'll talk more about functions soon. This was just as an answer to that question, like how you could do it. Yeah.
Quick question. Is there a reason why you use colon and
Colon?
quotations? Yeah. Like you had just single colon, like not colons, but quotes.
Oh, single quotes.
Yeah.
Yeah, so you can
versus
use
double quotes.
either single or double is fine. I like single because it saves me one pinky press on the shift every time. But that's the only reason. It's totally up to you what you want to use. Okay, so just to move on, so we also have time for the data analysis part. There are other types of variables in Python. Now you've seen how to store a single value or a single string. We can store many things together also in different types of arrays. For example, one of the most common things is what's called a list. So I can say, okay, I'll make a list of things. And in that list, I'll have the number 1, I'll have the number 55, and the word hi. And if I execute that, that'll be saved, and then I do list of things, and it will print out exactly what I stored in that list. And as you might or might not have picked up on now, if you look here to the left of the cells, you'll have these numbers and it says in 9, in 10, out 10, etc. That's just a counter that keeps track of the order on which you executed those cells. So you know that, okay, I did that first and then I did that. Because sometimes I can now, just to show you, I can do this again, and now this becomes 11. So just so you know which order you executed it in, which might or might not be the same as the vertical flow from up to down. And if I want to grab one of the things from this list of 3 things, I can do list of things, and I can say 0. So an important thing in Python that might be a little bit different from, it's different from some other programming languages, but it's also shared among some languages, is that you start the indexing on 0. So if I index into this list and say 0, I get the first element. If I say 1, I get the second, and so on. And if I wanted to, I could also get a range of elements. If I do 0 to 2, I'll get everything from 0 up until, but not including 2. That would be the first and the second element. Yeah, the first and second element, which is index 0 and 1. Another data type this is the last thing, the second last thing we'll go through before we get into the data analysis part. Oops, sorry. It's what's called a dictionary. A list is kind of like just an array of values. A dictionary is more like a key value pair. So you have something that's associated with something else, then you want to store it in a dictionary. So for example, I can have different fruit colors. And when you create a dictionary, instead of this square bracket we had when we created the list, you'll have what's called a brace or a curly bracket. And you don't have to memorize these things. You'll have access to these notes afterwards. And it's kind of more to get you understanding how these things work, a conceptual understanding of how they work. So let's say, I know I picked tangerine, difficult to spell, orange, and then I can also create banana. So every pair of things I separate with a comma. The key and the value in that pair you separate with a colon. So if I want to ask now, I can ask this dictionary, okay, what's the color of a banana? I can say fruit colors. And sorry, I should say that when you see that something pops up really fast on my screen, it's because I'm hitting tab. So if you start typing something and then you don't want to type it out because you're lazy, you can hit tab and it will kind of automatically complete that word. I use tab completion a lot, and I recommend that you do that as well. As soon as you see something pop up here, it'll be like a reminder, okay, I should also hit tab. But let's go back to asking the dictionary what color a banana has. So then you'll, instead of giving it the number, we can now give it one of the keys, either tangerine or banana, and we'll get back the value for that key.
Sorry, so what's the difference between the curly brackets and the other?
Yeah, so if you have just this normal square bracket, you just give it an array or a list of 3 things, like item number 0, item number 1, item number 2. In the dictionary, I have a key to an item, like a word that I can use to index into that dictionary. So I can't get the first item from the dictionary, but I can get the value of banana, for example. Does that make sense? And dictionaries are very similar to how we'll work with data. That's kind of why I showed them. You'll see later kind of how you access columns and stuff in your data set.
The reverse linking as well?
Is there what?
Reverse linking as well, like fruit colors and you type yellow.
It becomes a little bit more complicated. So you can do it, but it's not as easy as doing this. So we'll not cover that right now. One more thing I'll mention before we get into other stuff is that you can do comparisons in Python. So you can ask Python, it's 1 bigger than 2. You'll say that's false. It's 2 bigger than 1. You'll say that's true. And if you want to know if something is equal to something else, you'll do double equal sign. And the reason for that is that we used a single equal sign for assignment already. So you must do something else. This you'll see also when we work with data, that it's important to compare some things, because often you want to get like, okay, let's get me all the rows in my data frame or my spreadsheet that has a value less than 5 in this particular column. And then we'll use comparison operators like this. So this is all what we've seen so far. It's all included in Python, however you install it. So if you install it through Anaconda, through some other mean, whatever, what we've seen so far will always be there. It's part of the core of Python, the standard Python library. If you want to do more advanced, or I should maybe say more specialized things, this exists as packages that you can install and then use. And the analogy here is that kind of like you have apps on your phone or like programs on your computer, you don't need every single program or every single app installed from the beginning. And because there are so many of them, they're all not installed by default. So you have to pick the ones you want and use them. And that's the reason why you have installed the Anaconda distribution, because that's a distribution specifically for scientific computing in Python. So it already bundles a lot of those common packages together. For example, we'll see now one package used for some mathematical analysis is the numerical Python package, and it's called numerical Python. And the way we use it is that we need to import it into our, we need to import this package to use it. So if I say import NumPy, nothing will happen, but you'll see that we executed this cell, and it says 22 now. So it has executed that line, there was just no output. And now I can use the functions within the NumPy package. So if I say NumPy mean, and then I give it a list of like 1, 2, 3, it actually calculates the mean of those values. These white spaces are, I just put them there because that's usually how they are. It's not, it doesn't affect the function. So this means that we're using NumPy, and we're using the function mean from the NumPy package. A function is essentially something like a recipe, as we mentioned before. So it takes some kind of input, it follows some kind of instructions, and it gives some kind of output. So if it would be a recipe, the input would be the ingredients, the instructions would be how to make bread of those, and the output is the bread. And here, it takes those values, calculates them in, and give it back to you. This is similar to if you would go to kind of the NumPy menu, and then you go to find the mean, and then you look up those, and then you it's like select those values if you were using a graphical interface. So how do we know which functions do exist? You'll get used to it, and you'll start to memorize them. But how do you know it from the get-go? So something I can do is if I just type in NumPy and this dot, if I now want to see everything, like the equivalence of just clicking the NumPy menu and seeing all the different choices, different functions, is to press tab. So if you NumPy.tab, you'll see everything every single function that you can use from NumPy. And if I start typing ME, it will start to do a fuzzy match, which is like it will find everything that starts with ME, but it'll also find things where ME occurs somewhere in the function name. Does that make sense kind of so far? Any questions on that bit? Yeah, 2 questions.
This is like a question from before, but could the keys of a dictionary be from different types?
Can keys be from different types?
Like one of them is a string, one of them is like an integer.
I won't say yes. Yeah.
So you had, in the beginning, you had import NumPy?
Yeah.
Is that a file? Like,
So yes, NumPy is like it's a directory on your computer with several files for the different functions. And that was already installed when you install Anaconda.
Okay.
So you can make your own packages and you save them at files, and there's like a official specification for how that directory structure should look, and then you could import your own functions if you want to.
Oh, I see, I see.
But yeah.
So sorry, just
Yeah.
to follow up. So we have we have tables in the SQL server, for example.
Yeah.
Where they have data files. Right?
Yeah.
So it would be like import and then a specific table from that name of the table.
But that's you mean the table would be your data?
Yeah.
Yeah. So you would use some function to read that table and load it into Python.
So it's not import. It's
No, you wouldn't. No, you wouldn't. The things you import are Python files.
I see. I see.
Yeah, but we'll see soon how you can do something very similar to what you said, but reading a CSV. So we just saw how you can find out which functions exist. If you want to know what a function does, you can either append or prepend this question mark, and it will give you a little explanation. So in the case of NumPy, it says that, okay, this is going to compute the arithmetic mean, and it says here, like, kind of what different options you have when you're calling this function. Again, we won't get into this too much because it's just an intro. We only have an hour. But briefly, you can see that the first thing here, the first thing that you always need to pass to this function is called A. And if you read under the parameter list here, we can see that, okay, A needs to be something that's array-like, containing numbers, which we're going to compute the mean from. And we can see that we passed a list, which is something that's array-like, because an array is basically something that's kind of like a sequence of things. And that's where you could pass that. I'm going to give you one tip here about how to use Jupyter, which I really like. Instead of typing this question mark, if you go to the command section here on your left, and you search for the inspector, so that's commands, and then you search inspector, and if you click open inspector, and then I'm going to click commands again just to get that away. Sorry, I just have to reload that because it looks a bit messy. So you should get something like this where you got a new inspector and it's empty. What I always do when I do data analysis on my own is I drag this tab to the right and I go to my notebook and I have to go back here. And now as soon as I start typing NumPy, it will show me information about NumPy in that window. If I do .mean, it will show me information about that function in that window. I love this. It's super handy. I recommend you to always use it. I'm not going to use it now just because I need the screen real estate to kind of show you things. So it gets a little bit messy if I have that up, but I always use it on my own, and it's great to quickly get information about what you're doing. Okay, that's so. As you get into programming, you'll notice that a lot of programmers try to optimize a lot of things, including how many characters you have to type or how few characters. So one common thing is in Python is that you don't just do import NumPy, but you give it a nickname that's shorter. And you do that as NP. So if I want to use something from the NumPy library now, I can just type numpy.mean, and then I can type my list again. It'll work exactly the same way as before. We gave the nickname of our own. Any questions on that so far? Okay, let's do data analysis. The package we use for data analysis in Python is called Pandas. And with data analysis, it's pretty broad. When I say it, I refer to spreadsheet-like data analysis when you have a data set that consists of observations or rows and different things you've measured, variables or columns. So, and the package for that is called Pandas, which stands for panel data, which is an econometrics term that I don't use myself, but I like knowing where these things come from. So if I say import pandas as PD, will be an asterisk when it was syncing. You'll give you a number. It knows that, okay, oh, sorry, you know that now it's done. It's an import in this library. And exactly like before, we can do the dot and then tab. And we could scroll through this list to find what we want. I know, so I will help you. We're going to read in an Excel. We're not going to read an Excel file. You could. We're going to read in a CSV file, which is just a text file, with values separated by commas, comma-separate value file. So you can go down to that list to read CSV, open, and now we need that URL that I pasted. So if you weren't in the beginning, I mentioned that in the issue where we had the information about this session, if you scroll down, I pasted a link there. And I'm going to copy that link. And that's how it looks, just so you know. And I'm going to paste this here as a string, which will work. There you go. If I do that, I get an output like this, which is like, and I'm gonna keep that up here so you can type it if you haven't done it already. I just want to mention that the output you get here, you can see that's kind of how it will look if you open in a spreadsheet program. You have these rows of observations and columns of measured variables. I'm just going to call this iris because it's the data is about iris flowers. I'm going to do that. Here I'm going to do iris. And here, just so you can see this, I'm going to do that. So that should be typed out on one row for now. I'll give everyone some time to do that.
On the board, the link to the web page.
Yeah, you can also go here and you find the link, you can just copy it and paste it. So now we have something that's called a data frame. This iris thing is the data frame holding all our data. So if you, in the case of SQL, as you asked before, there's other commands where you can read in an SQL file instead. Instead of displaying the entire data frame. What I did here was I used the head command, which only shows the first 5 rows. And that's kind of nice if you just want an overview of what's in this data frame. Similarly, I can get information about the data frame by doing iris.info. And it says that, okay, I have 150 observations. I have a total of 5 columns. They all have the same number of values in it. And non-null just means that they all had an observation. There were no missing values. And then just says how big it is in memory. And this is which type of data it is. So float here would be a number with a decimal. I'm going to go too fast. Is there someone who needs more time to type this in? Okay. Yep.
Can I ask a question? When we were doing numpy.mean, like numpy was a package, and now we're doing iris.info and iris.object. What's going on there?
Yeah, great question. So if you do something like numpy.mean, exactly as you said, we're accessing a function within this package numpy. And we did that with pandas also, but then this pandas function returns the output as a special pandas object, which is a data frame. We give that the variable name, and part of that data frame is that it has some functions associated with it. So in other packages like R, it would be more that you always use like a top-level function on a data frame. So if I would be in R, it will be more like this. But just a design choice in the language, and it has advantages and disadvantages. I like this because it means that I don't. If I just do head like this, then I need to know what to kind of put in there. And also, if I do tab completion in general here, I'll get a lot of things. If I do tab completion after my data frame, I'll get only things that are relevant to that data frame. And then you do an empty bracket because it automatically operates on the data frame as its first object. Does that kind of make sense?
Yeah. Thank you.
Yeah.
Can I sneak one more question?
Yeah.
Can you show how to bring up the inspector again?
Yes, for sure.
Chrome on a Mac.
So you go to commands, and then you go here and you type in inspector, and you can click it. You can also press Control-I, which might be Command-I on a Mac.
Command-I?
Sorry, that's only if you're in Jupyter Lab, and you might have opened the Jupyter Notebook. Can one of you guys check if he has the note? Okay, so Jupyter Lab is like the new version of the Jupyter Notebook.
Oh, okay.
I might have been a little bit unspecific when I asked you guys to open it initially, but you probably also have Jupyter Lab installed if you installed it recently. So if you open that next time, you'll have these tabs on the left. And I should also mention that these things are technically called methods instead of functions, but they work as functions. You think of them as functions. That makes sense. I think there was a question in the back also. So that was through this head method.
Yeah.
Sorry, say again?
Isn't this reader like?
Yeah, so if I just do iris, it gets everything.
Okay.
If I say, okay, I just want the first 5 rows, I say iris and just give me the head part of that data. And that function operates on, and you need the brackets also.
So it's like by default it would be like 5 rows?
Yeah, exactly. And if you want another different number of rows, you can type it in here.
Oh.
Sorry. Sorry, that's a good question. I should have clarified that. And if you don't understand why it is like that, you can have the inspector open and it will show you. Or since I don't have it, I can also press Shift Tab and I'll get this, and it says n equals 5 as the default value. If you want another value, just type that value in. You could either type n equals 10, or you could type just 10 because it's the only parameter you can pass. Good question. Okay. More things I might want to know is like, okay, what's the number of rows and columns? I can do iris.shape. The reason there's no parentheses here is because this is a value that's stored in this variable named shape, and the other thing was a function that we like called and it performed an operation. But this operation has already been performed, and we're only accessing that value. You can think of it as a technical detail for now. It's not really important. And you might run into trouble initially. Okay, which ones have parentheses, which one don't? Don't worry, like you'll get used to it, and it will just make sense, but it takes some getting used to. I'll do iris.head again just to show that, okay, what if I just want this column from the data? I can do iris, and then I can do bracket, just as with lists. How do I index it in the data frame? I say sepal, and you can even do tab completion. Now we'll get back only that column. If I do square brackets, type in the name as a string of a column in the data frame, I'll get back only values from that column. And if I use the head method on that, I'm limited to the first 5. And I'll do head a lot just because I don't want to like flood it with output. I want to keep my code so you can see it also.
Sorry, can you back up the one before where we're calling how many?
That?
Okay.
Yeah. Yeah.
So in Python, if you have like a function or method and it gets 2 parameters, should we always name them, or could we just give them one after the other?
If you specify them in the order they are specified in the function, you're fine. You don't have to name them. If you want to like turn them around, name them. If you want to do one, then skip one and do another one, name them. If you're unsure, always name them, and they will always work.
Yeah. Could you run the mean function on the iris one?
I could do like, yeah. I could do that. That's a little bit tedious to type. So Pandas has its own mean function, and now the beauty of it is that it's part of the data frame. So if I start typing m here, it'll be like, okay, it has all these functions that I can use. One of them is mean. So if I just type iris.mean, I get the mean of all the columns in the data frame. And you'll see that that's much shorter to type than this long thing. And if I just wanted one column, I could just add that name there.
So
yeah,
if I have a table that's at a frame, I won't be able to do that mean of my data frame unless it's an actual. It's already in the package. Does that make sense?
So as long as you read, so you mean you have like a spreadsheet in Excel or something. As long as you read it into Python, with it read Csv or read Excel, then it's converted into a data frame. So when Pandas reads a text file or an Excel file, it automatically represents that as a data frame in Pandas, and the data frame has all that mean and everything. Yeah. We'll do that later. So in addition to mean, there are a few, there are other things as you saw as median, etc. One good thing to start with to get an overview of how things look is the method that's called describe. As you can see, that's just one row, like it's just very little text you have to type in, and you get the number of observations, the mean, the standard deviations, the minimum, the different quantiles, and the maximum value of each column in your data. And now you can already start to compare that. Okay, if I would have to do that myself in spreadsheet software, that would take a lot of time. Here I just had to type a single word and I got all that information kind of for free or at a very low cost.
Just to note that.
Yeah.
It's not really each column, like it selects the columns that are stored numerical variables.
Yeah, exactly. If you had that's a good point. I said each column, but if you look at iris.head, you'll notice that there's also a column that says species. And because it doesn't make sense to take the mean or something of the species column, it automatically excludes that. So it kind of has some inbuilt smartness that it knows what's a numerical data and what can I do mathematical operations on and what can I not do mathematical operations on.
Can I give the mean just with one column?
Yeah. So if you remember what we did previously, we typed just iris.mean. If you want just one column, you just select that first. You do sepal length. That'll be just the one value for that column.
Can we change the fields that are then described, like it's mean and count, mean, standing, minimum, maximum? Can we change those parameters?
Yeah. So if you do the question mark, it will tell you what you can change and what you can't change. For example, one thing that you can change is that you can give it what percentiles you want. Instead of 25th, 50th, and 75th, you can type in your own. And then I'm not going to go through these other parameters now, but essentially all you need to know is here, so you can really include what different.
It's just a question.
Yeah.
Yeah.
Or if you have the object inspector up, that will always pop up on your right. Let's do that. And okay, so we saw that we had a call. Yeah, sorry. Go ahead.
How do you select two columns?
Yes.
Like search for columns instead of just.
If you want to select two columns, you need to pass it a list of those two columns. So just to show what that looks like, since the syntax for, sorry, I should have that up here. Let's just do this first. So a list of two columns could just be like, okay, sepal length, then comma. So it's exactly as how we made a list before. Is it width? Yeah. That's the list of those two columns. So instead of just giving it, so one column, we're going to give it this list. So then I do like iris, and now I have to do the bracket for indexing, and then there's like a double bracket because the list has a bracket, and then we'll select those two columns. There's also, I'll just mention this because we don't have time to go through it. There's a special, oops, no, I'm not thinking. There's a special, more powerful indexing function method that's called loc, or loc, L-O-C for location. If you do iris.loc, you can not only, you can do exactly like this, but you can also give a range of columns. For example, if I want to have from sepal length to petal length, you can do like sepal length to petal. So this will actually, so it doesn't give me any values because when you do loc, you have to say how many, which rows you want also. And if I just say, okay, the colon is shorthand for give me all the rows, but I could do something like 0 to 5. And then you get the row 0 to 5, and you get the everything from sepal length to petal length, which includes that one in between. I realize we're running a little bit short of time. If people need to leave at 7 o'clock, feel free to go. We have maybe 15 minutes. I can cover an additional 15 minutes of material for those who want to stay. So one thing that's common to want to do when you do data analysis is you have some variable that's like grouping your data. In our case, it's the species. So what we want to know could be like, okay, how many different species are there in our data set? So if we do iris, and then we say species, and then we say dot unique, it will give us the unique values within the species column, which is the 3 different species that this data set consists of. So now I might want to treat those 3 species separately because they have different properties, and I'm interested in the differences between them. So to work with data like this, it's usually referred to as the split, apply, combine paradigm, which basically is I'm splitting the data into groups. I'm applying some kind of function. In this case, we'll do the mean, and then I'm combining the results into a table. So what I'll do here, I'll say iris, and I'll say, okay, group my variable, group all the data by depending on which species it's in, and then take the mean. So doing this now splits it into the different species groups, then applies the mean function, the mean operation, and then combines it back into this table, where we have one mean value for each column for each species. Does that make sense?
It's easier than R.
It's easier than R? I love this. Can we have I need to forward this. So we have another instructor who loves R, and R is great, and Python, both are great, but we usually have like a little battle for fun. So I'm going to forward your comment.
What was the function on the top? The method? The other?
Sorry, the min method?
No, the other one. Unique.
Oh, unique. Yeah, sorry. And if you want the number of unique things, it's basically number of unique. You add an n there, and it'll say there are 3 unique ones. But we'll keep it as unique for now. Another common thing is, so if we copy this, just copy your text and paste it into the next one. That's usually what I do. Or, oops, sorry. Or I would even like just change it up there. Like go back, you're going to use a new method. So something else that's common is that you want to know how many observation are there of each. And if you don't want to do describe or something, you could get it by the size. So I'm saying group by species and tell me how big, what's the size of each of those groups. Okay, let's do a little bit of data visualization, and that will kind of conclude our this session. So for data visualization, you can use some of the visualizations that are built into Pandas through the underlying kind of mother of visualization libraries in Python, which is called matplotlib. We will use another library here that builds upon that library and makes it a little bit easier to do some common statistical plots. This library is called Seaborn, and you can just remember that. You can't really remember that because that's a reference to like a TV character, but you'll get used to typing it. I haven't seen that show either. I don't know where it's from. But it's usually given the nickname SNS. So if you do import Seaborn as SNS, you'll now have all those functions by SNS tab. Sorry, SNS.tab. You'll see all the functions you can do with the Seaborn library. And we'll start out by doing something simple that's called a swarm plot. And that name might be unfamiliar, but you'll see what it and understand what it does when we look at it. So in this plot, I'll use the iris data set, and I can access the columns of this data set just by typing in those strings. So if I type, okay, let's do a swarm plot, and on my, okay, let's do this. On my x-axis, I want the species, comma. On the y-axis, I want the, let's do the sepal length again. And then the data I'm using is the iris data. So if you run that, you should get a plot that looks something like this. So essentially what this is that you have 50 of these dots in each of the different X columns. And that's one dot for each observation in that species. So it's called swarm plot because some people think this looks like a bee swarm or a beehive. Some people call it beehive plot, some people call it dot plot. Has many names. But essentially it's plotting all your data, and it's kind of taking this shape of distribution as well. This is a great plot if you're doing exploratory analysis on data sets that are not huge, because when you get into huge data, it'll be very crowded here. But it's like my go-to if I don't have too many observations, because it shows you every single observation and the distribution. Yeah. Like what kind of statistics? Like, yeah, like a distribution. Yeah. So you can't annotate it. You can annotate it with that, but that would require some like configuration. We will see some plots that plots just the min value also, like a box plot and a bar plot and stuff like that. So the cool thing now is that if I want to do another type of plot, it's the exact same syntax. All I need to change is the type of plot I'm doing. I'm going to copy this to a new row, but feel free to just change the previous row if you want, the previous cell if you want to. I'm going to change swarm to bar. So in the bar plot, instead of showing every distribution, it by default shows the mean values, but you can change that. You can show the median if you want, and it gives you a 95% confidence interval. Again, you can change that and show the standard deviation if you want. And just as before, if you want to change something or want to add a new parameter, if you look in the object inspector, or you press Shift Tab here, okay, that looks horrible. You press Shift Tab here, and you can read about. It takes a lot of different parameters, so there's a lot of customization you can do. We won't go into that because as long as you get the concept of how you do it, you can read up on that on your own and kind of understand the specifics of it. One common thing I like to do also is to combine two different plots. For example, and now I'm just going to copy from above. Let's say I want this swarm plot, but I also want a violin plot around it. All I do is that I write this twice, and I write violin instead of swarm plot, and you get that, which is not that easy to see. So then you can say that, okay, let's make all the dots here black. You get something that looks like that. A violin plot is also an approximation of a distribution. And this is just an example to show you how you could combine plots together. So you can use a different indicator for just a mean or something if you wanted. It's that would be totally up to you. Another thing that is common to do is to, instead of comparing one categorical with one quantitative variable, we might want to compare two quantitative variables, like for example, through a scatter plot. The syntax for that is to use something called linear model plot, which is short for that is ln plot. And then the rest of the syntax is exactly the same as we just did. So you can copy that line if you want, or you can just type it in again. But since we'll not use the same column names now, so instead we'll say, okay, let's use the sepal width, and then plot it against the sepal length. My data is still iris. And that way you get a scatter plot, and by default it fits this regression line, which might or might not be what you want. If it's not what you want, you can remove it by saying fit regression line equals false. Sorry, I can't get it into full view without getting rid of. It's more important that you see what it says out there. So that's how you would put two of these variables next to each other. So you can kind of see here that there are almost, like there's almost groups in this data, like maybe there's one group there, and either two or one big group here. What do you think those two groups correspond to? Is there something in the data that could explain why we have those groups here? Yeah? They could be, so we can try to find that out. One great thing to find that out would be if we somehow could color these dots according to the species they belong to. Then it would be very easy to see. If I go back to the same function I used before, I'm going to make a new line here, just so that you can see it and it doesn't get too long. It's totally fine to break something into two lines if you have an open parenthesis like this, because then Python will understand that just continue on the next line until I hit that matching parenthesis. And sorry, I didn't write out here that I wanted x equals. It doesn't matter because we have them in that order, but I'll write it out just to be clear. And to group something by color, we say you group it by the color hue, and the short for that is just hue. So if we say that the hue equals species, sorry. Okay, let's zoom out. Is that too small in the back, or can you still see? It's fine, okay. So now you can see that just by saying, okay, color my dots according to species, not saying which species is which color, you get this plot where the different species take on different colors. And you can see that this cluster is definitely because there are different species in the data. These two are a bit more intertwined, but that's just how this data looks. So this is one of the strengths of a Seaborn. It's kind of high level, and you don't have to specify specifics of what is which color. You just say, okay, group by species. Another thing we could do here is that we can say that, okay, I actually want one plot for each species. So I could say I want one column for each species. So through very little code, you get a pretty, like not a super advanced figure, but you get some kind of more than just like a basic single figure. And it would be really tedious to do this in something like a spreadsheet. What time do you have? Okay, I should round this off. And this column, you can also say row, and you can say how many columns you want and if it should wrap after a number of columns. I invite everyone to read more about that in documentation for this. And we also have a longer version, like a 2-day workshop on this, which we'll link afterwards, where you can read more about the specific parameters and things like that. Should this be the last plot? Maybe this might be the last plot. But one of my favorite plots is that whenever I have a new data set, kind of what I start with to explore that data set graphically is a pairwise scatter plot. So you plot every variable against every other variable in order to see if there's some relationship between those variables. In Seaborn, this is called a pair plot. And the syntax is just pair plot and then the name of your data frame. You don't need to specify the columns because it gives you all the columns by default. If you run that, you get something like this. There are 2 more rows, which we can't see because I need to keep this visible. And basically here on the diagonal is the distribution of every single variable. So this is the distribution for the sepal length. This is the distribution for the sepal width, and so on down there. The thing you see on the bottom half are the same as you see on the top half. So below and above the diagonal is the same data, just plotted inversely on the y and x axis. And if you go, I forget, what did we have before? Sepal width and sepal length. So if you go down to, oh, sorry, actually up here. So sepal width is the second column, sepal length is the first one there. So this plot and that plot, but we plotted it like that before, is what we have up there. And if we want to color this plot, what do you think I need to type according to species? It's the same syntax. Let's say hue equals species. And now, and you can imagine if you have more categorical variables than just species, you could keep plotting different ones of them, or you can break one out in columns like we saw before, and one is the color, one is the rows. You can kind of dig into your data visually like that. This is super powerful. The syntax is pretty straightforward. You need to get used to it, but it's not too much to memorize. And it'll save you a lot of time versus doing things like this by point and click. I think we'll stop there because I'm already over time and everyone needs to go, or some of you. But there's more a little bit more in the lecture content. And I will also link in the issue this workshop we had. So anyone who wants to read more has 2 days worth of material there. Yeah, any last questions before we end? Okay,
is there any way to find the correlation between 2 properties?
Yeah, I mean, if you just want the correlation coefficient, yeah. you can, yeah. What do you think I should write now? Yeah? CO, and then pad maybe. We can look through this. There's something called core. That could be a good candidate. And that's a correlation coefficient for. It doesn't give you p-values by, you have to, if you want p-values, you have to get it another way. But this is the correlation coefficient themselves.
Okay, could you just give it 2 different columns?
Yeah, you could subset it by columns as we did before. It doesn't always work with type notation. And you get only those 2. Well, is that what you meant? Yeah. Now you could even do, okay, now I just want to show this because it's cool. You could also, say I wanted to color this. I could make a heat map, I think. Like that. And you would have the correlation coefficient plotted out on that color scale. And we can do you just can specify a color map and stuff. All this you can read more about in other material. But yeah, that's how you get it. Any more questions? Okay. Thank you guys so much for coming out. We'll have two following weeks. We have 2 more advanced Python lectures looking more into statistics next week. And then the week after that, it's going to be web scraping, which is a little bit completely different. Yeah, thank you all.